In this video, I'm going to explain about a key component of SDV that is widely used terminology in automotive sector. The traditional automotive software development include the AVN and telematics, ADAS, and ECU. But these days, trend of automotive development is move on to the SDV because if you are involved with your project based on SDV, then it will reduce the number of ECU and eventually it will optimize vehicles component. So in order to understand how the SDV works, and if you'd like to see the key component of SDV, the first terminology you have to understand is the high performance central computer. When it comes to SDV, and you may hear about central computer. What is central computer? What is high performance central computer? This computer is providing the high performance feature. The frequency of CPU core is up to 3 GHz or 4 GHz, and the number of the CPU core is more than 12. And then size of the main memory in the high performance central computer is more than 12 gigabyte and more than 20 gigabyte. And then if you think about the primary software stack inside high performance central computer, then there's a software stack you have to understand that is hypervisor. In general, hypervisor is the main software stack in high performance central computer. Then under the supervision of the hypervisor, the several guest OS can be running simultaneously. In this slide, and first guest OS is taking care of the perception task, and the second guest OS is doing some of the job related to mapping, planning, and the third guest OS is performing the task, and that is responsible for ADAS feature, and then last guest OS is associated with infotainment system. And if you actually refer to the reference manual of the car OEM, then what you can see is there are more than 6 guest OS or more than 10 guest OS in the one single system. And in order to understand the component of SDV, the first thing you have to understand is why SDV was introduced. This is the background knowledge of SDV, and then this is another important question if you would like to learn about SDV. The first reason why SDV was introduced is to reduce the number of ECU. As a result, we can optimize vehicle component. That is the motivation behind SDV in automotive sector. So let's take a look at these figures that illustrate how SDV works in vehicle system. And this left side figure is the traditional structure of automotive development model. As you can see, there are many ECU inside the vehicle. But on the right side, and what you can see is the DC and ZC, and those box is indicating the central computer inside the vehicle. Then another important thing you can notice is that the number of ECU is decreased when it compared to the left side in this figure. So trend is changing from traditional automotive structure that is consisting of a lot of ECU unit inside vehicle. Then if you place the high performance central computer inside vehicle, and then all of the ECU can be controlled by the high performance computing unit, high central computer. So with this structure, we can minimize the number of ECU inside the vehicle. Let's take a look at another figure that shows you the structure of the ECU in the SDV. As you can see, there is central computer. This central computer is running with very high profile feature. Its frequency of the CPU core will be of more than 2 GHz, more than 4 GHz, and its main memory, the RAM size, is at least more than 20 GB. With the control of central computer, then ECU and execution of the ECU can be managed by central computer. Using central computer, we can expect that number of ECU is decreased. Now let's take a look at another figure that illustrates the structure of the vehicle based on SDV. In this figure, and you can see the two central computer. In each central computer, there is switch. And as for this case, there is another switch and another switch, and you can see John ECU. So if you place the central computer inside the vehicle, and then number of the ECU can be interconnected with the switch or gateway, and then this kind of structured some architectures of the vehicle will optimize the overall design of the vehicle. So that is the main concept of SDV. As sometimes the software image should be updated after modification of the software made on several ECU. But in this case, central computer will take care of this operation. Then you will perform the over-the-wire operation. What I mean is download for specific ECU will be performed by central computer. And sometimes central computer might detect the failure of the operation in particular ECU. In this case, in the particular scenario, central computer may reset the specific ECU to meet the requirement of functional safety. So on the control of the central computer, we can expect that the primary unit of the vehicle is optimized. As a result, we can optimize, decrease the number of ECU inside the vehicle. That is the primary concept of SDV. Now that you got to know what the SDV is, it's time to summarize what we have watched so far. Then the motivation of the SDV is to reduce the number of ECU. As a result, as I stated in the previous slide, we can optimize vehicle component. And then another important thing you have to remember is that primary mains of the stack in the SDV is hypervisor, because in the central computing unit, hypervisor is running. So I think that once you watch this video, and then you will understand the primary concept of SDV. Hope this material is helpful for your development. See you next time.